Okay, hi everyone. I guess I can begin. Hola, bom dia. My name is Alina, and I'm here to talk with you about GraalVM and everything you need to know about GraalVM to build your Java applications using it. So let's go. And first, a quick introduction. So this is my name, and this is my handle on all kinds of social media. You can find me there if you want to ask a question, ask for the slides, ask for the demos. You can do it over there. And I work as a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is this very cool R&D unit at Oracle, where we're doing a lot of R&D and brand new bleeding-edge projects. And what's funny, or like rather interesting, it originates back to the Sun Microsystems days. It used to be Sun Labs, and now it's Oracle Labs. And I love open source and communities. That's why I like coming to places like here, where I get to talk to people in person. And I love both programming and natural languages. I don't speak much Portuguese. I can say maybe like 5, 7 words, but I'm very open to learning more if you would teach me during the breaks. And I'm both a cat and dog person. I have a cat, but if you prefer dogs, don't come after me. I love dogs as well, and I hope that one day I can have a dog as well. And the last thing, this is my photo, so if you want to ask me something or follow up, this is how you can find me. Now let's go and talk about GraalVM. So the first thing to keep in mind about GraalVM, because it's a big project, so it can be a bit confusing what it is and what it can do for you and when you should use it. So the number one thing is that it is a JDK, just like you might be using OpenJDK, Oracle JDK, whatever is a JDK of your choice. And GraalVM is a JDK just like that. And we are pretty much not removing anything from the JDK. We are just adding things on top. So one thing that we have added is a new JIT compiler. Like in OpenJDK, you would have C2, and we added the GraalVM JIT compiler, so our own highly optimizing top-tier compiler. And what is interesting is written itself in Java. So a compiler, maybe it's not so intuitive how you can write a compiler in Java, but we did, and then we compiled it ahead of time into a native executable using our own native image to eliminate that possible warm-up and startup curve. So that is one thing that we added to the JDK. And another thing that we added, I will not talk about it today, but just for general awareness, is that we added this language implementation framework. So maybe you have heard that GraalVM is kind of a polyglot VM. So you can run JavaScript on it, you can run Python, you can even implement your own language. If you always wanted to have your own language implementation and be a language author yourself, you can do it with GraalVM. We've even seen some pretty interesting projects such as PHP on GraalVM, C# on GraalVM. So if you always wanted to implement something like that, you can totally do it with GraalVM. But the biggest part of it that I want to focus on today is this native image ahead of time compilation. And that is a part that makes GraalVM stand out compared to all other JDKs. So it can do what other JDKs can, just run your Java with the JIT compiler. But what makes GraalVM different is that you can compile applications ahead of time into native executables. And that is something that only GraalVM can do. And also, I like to use this slide to answer this question that people ask me at conferences sometimes, and they want to make it like a tricky question and ask me, when should we not use GraalVM? And my answer is always use GraalVM, but decide for yourself which part works best for you, right? So you can just do normal JVM stuff if you want to stay on the JVM. And then with the GraalJIT compiler, you can get maybe 10, 50% performance improvement. And that's a very easy migration path where you just download it and set it as your JDK, and you can easily have a bit more performance. Or if you are willing to go all in with the native image, you can get additional benefits such as startup time, memory usage, etc. And I like also showing this slide because I think it's a beautiful slide design, so I'm just very proud of our team's design skills, But also it highlights all the work that we did over the years to make GraalVM as useful and helpful and production ready as it is now. So we started working on it back in 2011 when my boss, Thomas Würtinger, joined the Graal team. And I like to highlight a few specific things here. So in 2019, we ran with our first GA builds. So until then, we were releasing release candidates. It was not production ready. But since 2019, we have actually generally available production-grade builds. Then back in 2020, Alibaba moved to using native image in production. And I like showing this because many people think the GraalVM is this, groundbreaking, new, revolutionary technology, maybe a bit scary. And I can definitely see that. But also, there are people who have been using it in production for 4 years now and under huge load. You can imagine Alibaba, what kind of traffic they have. And they have been very happy about it. And one more milestone that is dear to my heart. So in 2022, Spring Boot introduced GA support for GraalVM. So since 2022, you can also build kind of production-grade, out-of-the-box supported applications with GraalVM and Spring Boot. And a few words about native image, and then we will see how it works in action. So what native image does for your applications is when you run the native image command and you give it your application, and as input, we are taking bytecode. So you need to give us a jar or your class files. So what we will do is we will look at your application, starting from its main entry point, and we will try to find all the code that we consider reachable. So all the code that your application actually uses to do what it's supposed to be doing. We will analyze the app, and we will find all that code that is actually needed at runtime. And then we will include only that code into this produced native executable. And this applies to the code that you wrote yourself, but also all of your dependencies and even the JDK classes that you are using. So we will analyze the whole project, and then we will include only the things that you are using into the native executable, and we will eliminate everything else. And this way, your application can be run and ready to be used by itself, and it doesn't even need a JVM to run, because everything you might need is already included into this native executable. So this is one part of the story, and often native image, people call it ahead-of-time compilation, and it is true, but this is not the whole story. So one more thing that we are doing there is heap snapshotting. So as we are discovering and building your application, we are also looking at your heap, and we are looking at which objects are safe to initialize at build time, so that we can take kind of a snapshot of your heap and prepare it for you and include it into this native executable. So you can also start faster with this prepared in advance heap, a version of the heap. And in the end, what you have is a native executable that is also, as you can see here, is platform specific. And then it can run natively on the platform. It doesn't need the JVM to run. And I will talk with you more about benefits of native image, but I would like to start with a demo so we can show it in action. Let's see. So the first thing I want to look at is a Spring application. And there's a bunch of classes here for later on demos. But for the first one, let's focus on the fact that this is a Spring Boot app. And it has this controller over here that exposes an endpoint. So let's go ahead and see if we can run it. And let me just clear this and remove. OK, so I've been saying that GraalVM is a JVM, right? So we can also check what we are running on. And here I'm running on Oracle GraalVM version 23. So this is not even released yet. As you know, Java 23 will be released in September, and GraalVM for JDK 23 will also be released in September along with Java 23. But you already can get early access builds and give it a try and be this early user. And what is also very cool, if you're using SDK Man, can you raise your hands if you're using SDK Man? I am as well. I think it's awesome, and everyone should use it. So if you're using SDK Man, you can also install just like I did. OK, this is very annoying. How do I make it go away? Cancel. OK, hopefully this will be enough. Let's go back. Yes, what I was saying, if you're using SDK Man, you can install GraalVM 23 early access builds and just use it by default. That's what I'm doing. So as I said, it is also a JVM, right? So I can just run my Spring application on GraalVM as the JVM. Let's go ahead. It starts, and then it starts in something like 1.1 seconds. And if we go to our endpoint, OK, I think I would need to remap the ports, because this is taking longer than it should have. Let's see, 8080. OK, now it's on. So our endpoint is working as expected, all good. But it's just not particularly exciting, not particularly fun, if you ask me. So let's go ahead and compile it to native. And for that, I will do Maven. And I have a bunch of profiles, but I will just do a plain native one. So Maven pnative native compile. All good. So now what will happen is that native image will look at our application, discover what is in the app, and then compile it ahead of time into a native executable. And now, as this build runs, this is the time when some people start losing patience and start complaining to me, Alina, this is taking so long. This is taking longer than building on the JVM. I don't have that kind of patience. And I understand how that can be the case. I also don't have a very big, OK, this is annoying. How do I make it? OK, good. So when we were the build, so this can take a while, especially for a bigger application, but there is a lot to be done. So as I said, it will discover your whole project and will analyze and make this kind of universe, so build an understanding of your complete project ahead of time. And you've seen my app. It's a fairly trivial one. It's maybe 5 classes. But even for that app, we see that there are 17K types. So types are primitives, classes, etc. And where is the analysis part? And even for that smaller application, there are 26K reachable fields. So what I'm saying here, even such a small app, if you're using a framework, if you're using JDK, etc., it is still a fairly big project, and analyzing and compiling and optimizing ahead of time should take some time. And that's also the time that JVM would spend at runtime, only maybe you wouldn't notice it because it will distribute those efforts more evenly around the runtime. But with native image, we offer you a trade-off where you're doing all this work once at build time. And then when you start your application, you don't need to do the things that the JVM will do. So you don't need to load classes, you don't need to profile, interpret, compile, optimize. We offer you a trade-off where you can do it once. And I've been talking for a while, but in the meantime, our build has been complete in 48 seconds. So I think this is not too bad. And now if we go ahead and check out what was the result, we have our demo application compiled just now, and it's 62 megabytes, so not too bad for a self-contained full web application. And also, if I want to, I can reduce this number down even further. So if I care about the packaging size, there are tools that can help me compress it, but I don't care much, so by default, it's 62 megabytes. So let's go ahead and run it. Target demo, and if you remember, the JVM version started in something like 1.1 seconds. Now this one starts in just 46 milliseconds, which is pretty cool. And then when we go back to our endpoint and we update it, we see that it's doing the same thing. So exactly the same job, but it starts much faster. But it's not the only benefit. So let me go back and let me do a quick and dirty, like not benchmarking, but performance measurements, let's say. So let's do this, user bin time -v. And I'm running the same application, only now I will also observe its performance with the time command. So let me go back to the application, and let's emulate a user behavior where we are like coming to this endpoint and updating it to see how our application performs. Maybe we have it deployed somewhere as a web server, and it needs to serve those requests that are coming from the users. So as I'm speaking, I'm also updating the page. So let's say I've sent maybe, I don't know, 25, 30 requests in 5, 6 seconds. So let's kill it. And let's take a look at what we see. There is a bunch of things here, but the one that I want to focus on is memory usage. And in this case, it's, well, not exactly, but let's say 73-ish RSS usage, so memory usage at runtime. And I think this is pretty cool for the Spring Web application that is deployed and is serving our user requests. And if I want, I can optimize this number even further down, but I didn't do it. So this is out of the box, how little memory my application is using, even having access to my whole machine and being available to use as much as it needs. And if I wanted to, I could have taken this number even further down. So I think memory usage is a very important metric, and also like the way other people talk about this. So 2 years ago, when Josh Long and James Ward were presenting Spring Native, they did similar measurements, and their application was consuming about 100 megabytes of RAM at runtime. And they talked about it this way. They asked the audience, so how many of you are deploying a Java application and giving it 1 gig of memory? And quite a few people raised their hands, obviously. And they said, you know, so for the memory footprint of that app, you can deploy 10 such applications, or if you want to reduce memory usage, you can deploy 1 and just divide your memory usage by 10. So I think this is pretty cool, and this is achieved by compiling your application ahead of time and not doing all of that work at runtime like JVM is doing. So now we have our basic application, and let's talk about what's in it and how is running on native image different from running on the JVM. So if you have heard one thing about native image and why you might want to use GraalVM at native image, you probably have heard about fast startup, and we also have seen this in the demo now, where your application indeed starts very fast, much faster than on the JVM. And I think we can agree that this is particularly interesting for things like microservices, serverless workloads, maybe even more workloads in the cloud. But what if I have a long-running application that I build and deploy, and then it runs for, I don't know, hours, days, and weeks, and I don't care about startup that much? And I agree with you that startup is not the only metric you could be caring about, but luckily there are more things where native image can be helpful. So the next thing is what I just mentioned in the demo before, is lower memory usage. So you've seen how much less memory native image application is using because we don't have the JVM at runtime anymore, and we don't need to do all of that like overhead and code compilation work at runtime, unlike the JVM does. So this way you can use less memory, and this could be helpful, I think, either in the cloud, where you're paying for your resources that you are using at runtime. So if you can use less memory or for less time, you would pay less. Or even if you have your own infrastructure, you can reduce those infrastructure costs. And also there is I see a lot of this trend lately where people are trying to make our applications more green. So use less memory, less CPU, less electricity even. So if you want to save the planet, save the forest, save the turtles, native image can help you with that as well. Another aspect of native image is predictable performance. We will see it later on where we will be doing a load testing kind of demo application. And this means that the performance of your application is very even over time. So for the first milliseconds, if you think of peak performance as, let's say, requests per second, and you imagine it as a chart, it will be very stable and very predictable. So again, maybe for cloud deployments, or if you have some SLAs for your users, this can be very beneficial. Whoop, what happened? Go back. And there is another interesting aspect, and that is that native image adds an additional security layer on top of the JVM, because we compile the application ahead of time, and then some things such as serialization, reflection, etc., are possible in native image, but they require additional kind of allow list and awareness and OK from your side to make those things happen. So they eliminate some of the attack vectors that are on the JVM, and we will talk about that in a second. And also, as we have seen, the applications that you will build with native image are more compact. So again, for cloud deployments, where you want to have smaller container images, you want to deploy them faster, you want to scale them more easily, this can be helpful. And now in 2024, if you remember the timeline, now we have support from all the major frameworks and cloud vendors. So if you're building a new Java application now, there is really no reason for you not to be using native image. It's very easy. Now, let's talk about native image and libraries and frameworks and what are the challenges there and how you can make specific libraries and frameworks work with native image. So one thing about native image is that you've seen we are building applications ahead of time, and this needs to happen under a closed world assumption, meaning that everything there is to know about your application needs to be known at build time because the runtime hasn't happened yet. So whatever needs to happen at runtime, there needs to be a way to tell native image that, hey, for example, this method will be called at runtime, or this resource will be loaded at runtime. And this poses a challenge for some more dynamic Java features. So for example, reflection. I don't know if people in the room, can you raise your hand if you have heard that GraalVM doesn't support reflection? OK, quite a few people still a way to go for me. So GraalVM does support reflection, but there are things to know. And the things to know are the following. So some of the more predictable, more kind of trivial and reasonable calls to the reflection API, native image can detect out of the box. So even out of the box, there is like automatic detection mechanism where it will look at your application, it will detect those calls, and it will try to register them automatically. But then if you're doing something more advanced, or maybe more unpredictable, or maybe your library is doing something that it was harder to predict, the way to make this work for native image, so the way to make this information available at build time, is to provide configuration for native image and to tell, hey, those things will be happening at runtime. Can you please build an application that is aware of those features? And can you please include the possibility for this as you are building the app? And this applies to reflection, serialization, resources, proxies. So all that works, but that configuration needs to be provided to native image. And this doesn't necessarily mean that it needs to be coming from you, so you don't need to necessarily write JSON files. but it needs to come from some source, and ideally it will come from a library framework where they will include this config and make those things available to native image without you maybe even realizing what is happening there. And I want to illustrate all that I just said on the example of Spring Boot and how those things happen in Spring Boot. So the way Spring Boot normally works, so let's say before GraalVM, is when you start your application on the JVM and it starts for the first time, it needs to discover your whole application and make sense out of it. And as a part of it, it will pull the configuration from all the different places to build this kind of universe and understanding of your app and pull all the pieces together to build your project, basically, at runtime. So what's interesting, native image is doing pretty much a similar thing. So it will try to explore your application and build the whole project and build the understanding of it and also pull the config and put them all in one place. But Spring Boot does those things normally at runtime, and native image wants to do those things at build time. So they're doing a similar thing, but at a different point in time. And to bridge this gap, there was introduced this new module in Spring Boot called Spring AOT. And this is something that brings those two things together into one place at one time. And what Spring AOT does, it's a new kind of module engine in the Spring framework, and it works as a part of your build process, where it will look at your application and it will transform it in a way that is kind of easier for native image to understand and make sense out of. And as a part of the transformation process, it will also produce three kinds of things. So it will produce Java source files. For example, for your configuration, it will transform it into a more functional style configuration that is easier for native image to understand. It will produce bytecode for things like proxies. And it will produce so-called hint files. So those are those config files that native image can look at and make those things, such as reflection, available for your build. So this is a bit complicated, but luckily, most of the complexity is hidden from us by Spring AOT, and it just does those things automatically for you. Now, with that being said, let's maybe first look at demos, and then I will talk about how you can make more libraries available to native image. So let's go back here. And I think I want to start with this one. So how many of you have tried using LangChain4j already? OK, some. Tim, obviously. So I have this small, like the most basic LLM application that you can do, where we have our app that just starts and takes an input from a user, and then passes that input to the OpenAI API. And we are using the latest and greatest, so GPT-4o, just released a couple of weeks ago. And then our model and our application will generate a response for us. So let's close all of this, and let's just get to the good part, where we already running this in the native mode, and it will work just the same in the JVM mode. So I have my application compiled over here. Again, everything is included over there. So let's go ahead and run it. And we need to ask it something. So let's maybe ask, what is GraalVM? And let's compare with what I said. So people have been promising me that GPT-4o is very precise and very fast. I don't know, maybe it's a network call, but it's my observation that it's not as fast as GPT-4, let's say. But anyway, the response is here, so let's see. It's a high-performance runtime that provides support for multiple languages developed by Oracle. OK, it's nice and precise, I would say. And you can see how the application was fairly fast. There is a network call, so it's kind of hard to interpret the performance. But overall, I would say it's quite fast. And it ran without any, it was built and ran without any config from my side. So it just works with native image, and it's very easy to use this library. So just to make sure that this app is not, like hard-coded any response in it, let's go ahead and ask something else. So maybe we can do, who is Thomas? And let me see that if I got it. View everything. OK, I hope I spelled it right. Let's wait a second. OK, computer scientist, working on the GraalVM project. OK, pretty correct. So I think this is a good illustration of how you can use even like the latest and greatest and popular libraries in the Java ecosystem with GraalVM, and it just works out of the box without any config from your side. But this is not all. I want to show you a couple more demos. So for the longest time, people have been telling me that GraalVM seems like a great fit for CLI apps, because maybe you want your CLI apps to be self-contained, small, fast, etc. And there is this cool library called Pico CLI. I haven't tried it, I'll be honest, but many people said it works really great with GraalVM. I do want to show you something else that I have built, and this is using Spring Shell. So again, I have it already compiled, so we can just run it and see how awesome it is. And this is a Spring Shell application compiled to the native image. And what this is, in the essence, it's an implementation of the ls utility that just lists files and directories in the current or whatever user-provided directory. But it's hopefully made more cute, because the original ls is a bit boring, if you ask me. So let's go ahead and run this one. Target native Spring Shell. Yeah. And it comes out of the box with some additional kind of commands and tools, which is pretty cool from the Spring Shell. So it comes with help. There are some built-in commands. And there is my cute ls methods that I wrote myself. So let's run this. And I think you can agree this is a bit more cute than your normal ls. And again, there are some built-in commands, so we can retrieve history. It shows what we just did. And you can also quit this. And yeah, this is how it works. And you can even build more advanced things with GraalVM as well. And again, this is all happening without any config, any manual magic from my end. I want to show you one more application. And everyone is doing AI these days, obviously, so you cannot come to a conference and not show AI. So I brought this Spring AI application, which is a travel recommendation app, where we have an endpoint with a form that we show to a user, and then we are asking them for their preferences for travel, such as country, activity, the mood you're in. And then we are going again to the OpenAI API to provide a destination recommendation for our user. So let's check this one out. AI, and it's called Travel App. So it started in 0.05 seconds. So if we go here to localhost, I mean, the first thing that I want to point out here is, can you please appreciate this beautiful UI that I have wrote myself? It might not look like a lot, but I promise that it looks much better than it did in the first iteration. So I'm very proud of myself. So let's test our application. Again, this is all running in native, and the whole application with everything included is maybe 100 megabytes. So let's say we want to travel to Switzerland, because that's where I live. And the activity that we want to do is, let's say, hiking. I really don't want to, but this is kind of thing you have to do if you live in Switzerland. And let's say we are feeling adventurous. So let's wait and see if we can get a travel recommendation. OK, based on your preferences for Switzerland, hiking, and adventurous mood, I highly recommend visiting Zermatt. It's nestled in the Swiss Alps, blah, blah, blah. OK, I would say this sounds pretty good. But let's test our application some more, and let's see if we can get some more fun recommendations. So let's say we want to travel to Portugal, and we don't need to hike anymore. Maybe we can do cocktails. And let's say we are still feeling adventurous, so where should we go? I recommend visiting the... OK, I see laughs in the audience, so I can only guess that this is a good destination. But also, maybe you can educate me afterwards, what is this place? Because I've been to Portugal many times, and I have no idea, to be honest. But yeah, this is a Spring AI application that you can also build yourself and run in the native image mode. And then if you go out and check the size of our app, so this is my complete compiled application. It's 100 megs. And Spring AI, I believe, just went GA like last week or something. So now you can also build production apps with Spring AI and GraalVM and have the best of both worlds. So yeah, this was about libraries. And now I will show a slightly scary slide, but it's important, so I want to show it. Please bear with me. So I get a lot of those questions. How do I use library X with GraalVM? Or let's say I have an existing project that has a bunch of dependencies, and how do I know that they will work with GraalVM? And the main challenge there are those dynamic Java features that I mentioned, so reflection, serialization, basically anything that happens at runtime. So how you can make it work either in your own user code or in the libraries. And each bullet point here is a solution to that challenge. And you don't need all of them, so each of them is like a separate solution, going from the best case scenario to a scenario that requires a little bit more work from your side. So let's talk about this. So one way how libraries and those dynamic Java features can work with GraalVM is that they can be built out of the box, native image friendly. And we see this more and more lately, where people write applications in a way that maybe don't use reflection that heavily or make it in some way more visible to native image. So ideal case is when the library, framework, etc. is written out of the box in a way that it's easy for native image to understand. And we see more and more such libraries lately. That's a really nice trend. Now, if that is not the case, the next best thing a library or framework can do is they can provide this config for native image in the library itself as they ship it. And for that, I used to show this H2 demo, where I would have a demo that will break because it could not understand how to work with H2 in the native mode. But now it just works. I don't need to show it anymore, because since recently, since a while ago, H2 includes this reflect config within the library itself. So when you are building a project that is using H2, this will be included in the library itself, and it tells native image, hey, please make all those things available for reflection, so you can build your application out of the box without having to configure any of those things for yourself. So this is pretty nice, but the next thing is, let's say you have a library that hasn't yet added support for native image. Maybe they're still working on it, or maybe the maintainers are not convinced just yet that they need to do it. So what is the next best thing you can do? The next best thing that we can do is we created this centralized repo on GitHub, where you would think that, as a user, maybe you have discovered a config for some library. Let's say it was also H2. So why not contribute it to some centralized place, not like Maven Central, but kind of like, so that others who need to use the exact same library can do it and pull this config for you, because why would everyone discover it by yourself? That makes sense. So we have created a centralized repo on GitHub, where you can see a bunch of folders for each project. And this is the place where users, maintainers, authors can contribute config for native image. And then the best part is that this is also integrated with our Maven and Gradle plugins from the GraalVM team. So if you're building an app and you have our plugins added to your project, or maybe you're using a framework that adds those for you, such as, for example, Spring Boot does, all of those projects, if you're using them, our plugins will automatically pull config from this place. So this is not something you even need to worry about. So we talked about the first 3 bullets, and this is kind of a happy path, but also I hope that this is the path that most of you will take if you will be using native image, especially, again, if you're building a new project rather than migrating something older to GraalVM. But now let's talk about a case where there is no support yet for GraalVM in the library that you are using. So what can you do then? So the next, and we are getting to this gray area after the orange line. So if you're on a version of a framework that is supporting GraalVM, so let's say for Spring Boot, that would be for Spring Boot 3.0 and higher, when they introduce GraalVM support. What you can do is you can call this module in Spring to programmatically generate hints for native image. So here you can see an example of how this can be happening. So let's say I want to load this file at runtime, and I can call this API to say, hey, can you please register and make this available for me at runtime, so that you don't need to write config files, but rather do those things programmatically. And to show you a bit more practically as an example, let's go back to our native Spring Boot app. And I've shown you just the hello controller, but I have a bunch of other things there. So let's say I have this slightly weird reflection call over here, where if this was more predictable, native image could have guessed it out by itself. But this is written in a way to try and outsmart and confuse native image. So this just works in the native image build, because I have this class here that implements hints and tells the Spring AOT module, hey, can you please register this reflection call and generate those config files for me, so I can do this programmatically. And this applies to configuration for reflection, but also I can have the same thing for the resources. So let's say I want to load, where is this message.xml file from our resources folder. So again, I can call this API and say, hey, can you please generate hints to make this file available and visible to native image as it builds application? And that is a good programmatic way to generate those hints, those config files for native image. Now, let's say you're also on the older version of a framework and there is no support for GraalVM in anything you are working with. So the best thing you can do then is you can use our tracing agent that comes with native image to produce this config for you. And the way this works is you will run your application on the JVM with the agent attached to it, and you would emulate as much as possible your production workload. So let's say I want to load that message.xml file. I would make that call on the JVM with the agent attached to it. And it will look at that call, and it will produce this config file again for me. And this is a semi-automatic way to produce configuration where the agent will do this config for you. And now the last case, I hope you'll never get to this area, but the last case, if you're making just, let's say, one reflection call, and you know exactly what it needs to be, you can also write a JSON file and say, hey, please make this field available as you are building the app. But hopefully, this is a part where you will never get to. So this was maybe a bit more complicated and scary than what we've seen before, but if you want to work with libraries, this is maybe the most useful slide, I would say, in this presentation. OK. And we've seen more demos previously. And this is the page also on our website. So if you want to say, hey, I have this project, and I want to understand if I can run it as a native image, how can I quickly assess if my dependencies will compile OK to native image? And we have this page on the website called Ready for Native Image. And it's a very long community-maintained and contributed list of libraries and frameworks that are known to be continuously testing and integrating with GraalVM. This is a known list. There might be more libraries out there, but this is based on community contributions, a quick way to assess if your library will work with GraalVM. So if you want to assess your project, I would recommend that you go to this page and check out if your library is on the list. And then if it's not, you can still test it, but those are like bulletproof, proven to be working with native image. And I want to say a few words for testing. So we get this question, how is testing different in native image than it is on the JVM? And our recommendation in general for developing applications, but also testing, is that you keep developing your application on the JVM, and then you test for native image specifically in few cases. So one case is if you're introducing a new dependency, you might want to compile to native and make sure that things are still working OK. Also, if you are touching things that you know are sensitive to native image, so reflection, serialization, etc., or in your CI/CD, maybe like once a day, but you don't need to recompile to native all the time as you're developing your application, because normally things would just work. So again, only in cases when you're introducing something new, or if you are touching reflection, serialization, etc., then you would need to test. And when it comes to integration testing, the best thing you can do is look at your framework and what kind of support they offer from the framework itself. So for example, if you're using Micronaut, there is this great module called Micronaut Test Resources that helps you do integration testing, and it works with the native image as well, where they leverage under-the-hood test containers and help you test, let's say, your database dependency with GraalVM in the native image mode. OK, and let's talk about performance, because I work on a compiler, so I care about performance a lot. And it's a very interesting topic, and a topic where we're getting a lot of questions. So when it comes to peak throughput, how does native image compare to the JVM? And can I have the same peak throughput as I would have on the JVM? And there are a lot of myths and misconceptions in this area, so let's address that. And again, I want to bring a demo to show it in action, and then we will talk about how it works. Let me just close all of this stuff. And as a demo here, we will use a Spring Pet Clinic application, which is a fairly big application that is commonly used for benchmarking. Let me just move this higher up and clean this. And I'm sure you all know this app, but just to show what it does in action, I will already run on the native application, Spring Pet Clinic. And it starts, and it's compiled to native. It's a bigger app, so it takes a while to start, maybe like 200 milliseconds, but still, it started fairly fast, I would say, for a large enterprise-grade Java application. And then if we go to our localhost 8080, You probably know the app, so this is commonly used for benchmarking because it's a good representation of what you would run in production, where you can, I don't know, read data, add data, and it emulates a pet clinic application where you can have owners, pets, visits. So let's maybe not leak my personal address, but let's maybe add some another person. Blah, 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 and this gets recorded into database, and then I can add pets, add visits, read data, write data. So it's a good kind of standard benchmarking app. Okay, this is annoying. Go away. Now, let's benchmark this app, and I'm kind of proud of the benchmarking setup that I have, because this is like still not entirely scientific, but almost as scientific as you can benchmark at a conference. It will be complicated, but bear with me because I'm very proud of this. So we will benchmark this app in the following way. We will first run it on the JVM, and we will use GraalVM as a JVM, but we are turning off the GraalVM compiler. So effectively, this will be a C2 OpenJDK kind of setup. And then we will wait 10 seconds for the JVM to start before we even touch the application. Then we will warm it up for 10 seconds, and then we will do the actual benchmarking run for 20 seconds. So this is the setup, and the actual workload, we will try to emulate a real human behavior by creating new owners, adding pets, reading data, writing data. So this is as close to benchmarking as you can do at a conference. And also this is running on an isolated cloud instance, so not interfering with my slides or anything. With all that being said and done, let's move this higher up, and let's start benchmarking. So bench JC2. So first, it will run on a JVM OpenJDK-like setup. And now you can see the application is starting. It starts in 5 seconds, but just to be on the safe side, we are giving it 10 seconds to start before we even warm it up. So now we are warming up, sending the actual load, but not measuring yet because we want to warm up so we can properly benchmark a warmed up JVM. And now we are running the actual benchmarking load. So let's see. 20 seconds, so it will take a while. And we see that in the warm-up run, our JVM ran with, like, I would say, roughly 500 requests per second. But then the benchmarking run is almost 3x. But the warm-up run was a bit slower, which is obvious, but still one more thing to keep in mind. So now let's do the exact same thing, but in native image, where we will also run our application only in the native image mode. And now I started my app, and we will do the exact same benchmarking, only it's funny because now it seems like nothing is happening. And that is because I'm doing the same as the JVM. So I'm waiting 10 seconds for the application to start. Only the native app doesn't need to wait 10 seconds. We are just waiting 10 seconds as we were waiting for the JVM. So now we are warming up, and now we are exercising the benchmarking load. But we can see that even the warm-up run was already faster than the JVM. So let me scroll away, and let me ask you, so who thinks the native application will be faster than the JVM? OK, some people, but also you realize that I work on GraalVM, so I could have tuned the application to look better than it really is, right? So you didn't have a lot of faith in me, I can tell. But let's see. So the JVM completed the run in 1.5 requests per second. And then native image, its peak throughput at the benchmarking run was 1.1. I would say this is still good because it's very hard to beat the JVM at its own game. So I would say this is comparable performance. But obviously, maybe we're not entirely happy about it. Maybe we want to make it faster. So I have yet another version of this app where I have applied a few additional optimizations, and we will talk about which ones in the second. And let's see if I can make this application faster than it was in this out-of-the-box run. So we will run again for 10, 10, and 20 seconds, but we have applied a few additional performance now. Still not black magic, but some extra performance optimizations. OK, let's go. So this was the warm-up run, and now we are waiting for the actual benchmarking run to be complete. And to recap the numbers, the JVM was 1.4K. Native out-of-the-box was 1.1K. And now the optimized run is 1.7K. so on par and even slightly higher than the JVM. So I will show how it's possible in a second. But before I do, I also want to show one more thing. I talked a lot about resources usage in this presentation and how we want to save the planet, the totals, and everything. So as I was benchmarking the application, I was also recording the resources usage and consumption of each of the apps. So let's compare them side by side. This is the JVM. This is native image out of the box. And this is native image optimized run. And I think this is very interesting, so let's look closer at this. The way to read those charts is that red vertical lines, this is CPU usage, and the horizontal blue lines, this is memory usage of our application. And you've seen they all had the same kind of load that they needed to serve, but they have very different resources consumption. So they were all given 512 megs of memory, but let's look at what we see here. So one thing that we see, the JVM that keeps the CPU quite busy because that is a lot of work to be done when you start the application on the JVM. So it's loading classes, it's profiling, it's compiling, etc. And as it's serving requests, it's also keeping the CPU quite busy, while native image doesn't need that much CPU in either of scenarios. Now, when it comes to memory, you can also see that the JVM went, I would say, almost to 700 megs, especially after the first 30 seconds. And native image is very low, even 200 in the first run, and slightly higher in the second run, where we are using the G1 GC. And the first 10 seconds, when we were just starting our application, you can see that indeed the JVM is very busy for the first 5 seconds because it's starting up. But then native image started, and it's just waiting for us to get it some job to do because it doesn't need that startup time as the JVM does. So those are a few interesting observations here. And in this last run, what is happening here, we have more throughput. You've seen the application was faster, but also we are using a bit more memory. And I think it's a common understanding that if you want to have better throughput, you need to give some more resources, and usually those resources are memory. I see that I only have 3 minutes left, so let me show you, skip to the good part, and show you exactly what I did for the performance of this last app, so you don't think that I cheated in any way. So the way the last app is faster than the previous native image run is this. I did a number of things, and the first and the most powerful optimization that you can do is called profile-guided optimizations. And as you know, the JVM profiles your application as you run. So when you run an application, JVM looks at it, looks at which methods are more often called, which loops are more often executed, and it's specializing specifically for those scenarios. And then if something changes, the JVM can kind of roll back, de-optimize, and optimize again. And you would think native image cannot do it because runtime hasn't happened yet, but you can do PGO, and this works in a way where you would build an instrumented version of your app. Then you would run it, and you will apply relevant workloads, and it will observe the application behavior, and it will output a profile file, so kind of the similar thing that JVM does at runtime, but we can embed and consume it at build time to optimize for your application's runtime performance. And this way, we are kind of combining the power of ahead-of-time compilation with having information about runtime available, and we can also specialize, like the JVM does, for what happens at runtime. So if you want to have good peak throughput, this is the best thing you can do for it, but there are a few more things that you can also do. So in case, this is like a 2-step process where you need to do this like instrumented run, observe the application, collect profiles, and then compile again. And it's not always that you have the time and resources to do it. So if you don't do it, you would think that predicting the application's performance and profile is a good task for an ML model, and it is indeed. And if you have an ML model embedded in native image, where if you're not doing this first step, it will look at the application and will say, hey, seems like those parts will be hot, so it makes sense to invest compilation efforts in those parts. It will not give you as good peak performance as user-provided PGO, but it will give you maybe 6, 8 performance improvements out of the box, comparing to not having any profiles. And 2 more smaller things. Well, G1 is not smaller, but like one more thing that you can do is G1 GC. This is also what we saw in the last performance chart that I showed, where it used a bit more memory, but the peak throughput was much better. So if you want to optimize for peak throughput, you should use G1 GC in native image. And then the last helpful thing is this MARC native flag. And this is tell native image, hey, I will be running my application on the same machine that I'm building, so please optimize for those specific hardware features that you see on this machine. I'm not sending it to users, I'm not redistributing, please optimize for this particular machine, and it will also give you a few performance improvements out of the box. With that, I want to wrap up. I do want to mention two things super quickly. So we are working on this new project called Layered Native Images, where we'll give you a way to compile your dependencies as the base. And then every time you recompile your application, it will be just a matter of seconds, because you will only recompile your user code, the code you actually wrote. And this way, we think we will take compilation step down to just a few seconds. And also in the cloud, you will be able to share those base layers and reduce resources usage in the cloud even further. And we are working on something very cool called GraalOS, which will be a deployment platform for your application, so stay tuned. And if you want to ask a question or if you want to see demos, you can super quickly scan those QR codes, and I will be happy to chat with you. I will give you just a second because I see people are taking pictures. And with that, that was everything that I had for you today. I need to give the stage to the next speaker, but I will be here to answer your questions. Obrigada.